In this video, we're going to derive an expression for resistance in series and parallel. Now, you are already familiar with the relationships for resistance in series and parallel, and now I'm going to talk you through the derivation. If you find that you get it and you can proceed without it, there's something quite intuitive about the process, then stop the video and see if you can do it on your own. If you need me to talk you through it step by step, then by all means, watch the whole video. Now, the defining relationship for resistance is voltage divided by current. Basically, resistance is simply the ratio of the voltage across a component to the current flowing through it. As you know, in a series circuit, the current is the same everywhere. So, I1 coming into this resistor is going to be equal to I2 and I3. So we'll call that current the same, I. Voltage in series, however, splits. So your total voltage is going to be the sum of voltage 1, voltage 2, and voltage 3. Vt is equal to V1 plus V2 plus V3. Now we know that voltage equals current times resistance from rearranging this relationship. If V equals IR, we can substitute that in for our values of V1, V2 and V3 to give us IR total, the total resistance times the current, equals IR1 plus IR2. Now we know that current is the same everywhere in the circuit, so we can cancel the I's. By removing I from this equation, we're left with the general case. RT in series is equal to R1 plus R2. You can try doing this now for resistance in parallel, or you can watch the video. Let's consider this circuit in parallel. You know that the total current is going to be the sum of I1 plus I2 plus I3. The total current will be I1 plus I2 plus I3, as stated in this expression. We also know that voltage in parallel is the same. So V1 across here will be equal to V2 across here and V3 across here. Applying V equals IR throughout the entire section would give us the following equation. V over R is current. So, V over RT equals V over R1 plus V over R2 plus V over R3. Now, as stated previously, the voltage across all three is the same as Vt, it's constant. So these can cancel out, leaving the final equation, which is 1 over RT equals 1 over R1 plus 1 over R2, etc. And that's the derivation for these two equations.